right, thanks everyone for coming. Is the mic working? We're good? There we go, awesome. We're not gonna be talking about P this time around. Sorry everyone if you were there this morning. Today's talk is Navigating the Open Source Policy Labyrinth, and I'm Dan Lorenc. So I was gonna take a trip back first of all to start out here. The space actually kind of starts in 2002. In 2002, I was first learning how to program on a TI-83 calculator, but the world was very different back then. Computing was a lot different, but this is when governments actually first started noticing open source. There were a bunch of governments in South America that started writing the term open source into contracts and regulations then. There's a famous DoD memo about how open source could be used inside the Defense Department in the United States. But open source policy, it's moving fast now in a lot of directions around security, but this isn't very new. It goes back over 20 years when governments were first starting to encourage the use of open source, and now they're starting to kind of grapple with the consequences of that and the liability that comes from it inside of companies and the government itself. I like to use this meme too. I don't think anybody saw any of this stuff coming, open source being used in all of the critical environments that it is used in today when all of this first started. But one way to think about this is a long chain of unintended consequences. One Finnish dude releases a free Minix clone on an email client, and now governments all over the world are scrambling to figure out how to take this into account in their security practices. There are a few steps in the middle there, and in some ways it was inevitable, but it doesn't really feel that way if you've been watching it all along. I'm going to cover a couple main points today. I'm actually going to argue that I think open source does need regulations from governments. That's probably a slightly controversial point to make. It's getting regulated either way, whether we want it to or not. But I actually do think, because of the way it's used and some of the unique principles about it, that it does need to be regulated in some fashion. Then we're going to talk about the right and wrong way to do that. Anytime the government tries to help with regulations, there can be unintended consequences. And I think here it's pretty easy to mess up. And there are actually some examples of countries and groups that I think are regulating this and going about it the right way, and unfortunately some that are not. So first, why does it need regulations? Probably not for the reasons you think. Had to do a kind of clickbaity title here. But I have a couple warnings here first before we start encouraging regulations. People have probably seen this quote before. The 9 most terrifying words in the English language are, "I'm here from the government," and "I'm here to help." That applies especially to software development. I've met a lot of folks in the government, and unfortunately the ones writing the policies aren't always the ones that know how computers work the best. Thankfully though, there are a lot of hardworking people in the government that are trying to explain this and come up with the right way to do this so that way we don't end up slowing things down or making things much, much, much worse. The main point too that I want to make here, open source doesn't need regulation because it's insecure. You have to say this every time we talk about this, but open source by every metric is more secure than closed source proprietary software. There's tons of people, tons of experts working, fixing bugs in the open. All of that transparency leads to make open source projects patch vulnerabilities faster, fix bugs faster, deal with incidents faster. If you look back at the famous Log4j vulnerability, that was fixed by volunteers over a weekend within a couple days of the initial disclosure. Companies took months or years to remediate once those fixes were available. So it's not open source itself that's insecure, it's the way that companies and governments are using open source that needs to change. And that's where I think the regulation needs to be focused. Again, one last time, open source is not insecure. It is more secure by every metric and every study that I've ever seen, but it still does need some regulations because of the way that it gets used. There are 3 main points that I think kind of combine to make this the right time for regulations around security in open source. The first one, I think, is that it presents a unique concentration risk due to its ubiquity. Open source is everywhere. It's powering every critical system out there. Because of that breadth, and because everyone kind of mostly uses the same open source at the end of the day, this isn't something that you can kind of let the markets regulate themselves. It's in too many places, and the same software is in too many places that we do need to take a look at it because the consequences could be dramatic. The second one is that vulnerabilities and unfortunately malicious attacks on open source are rising incredibly quickly. Your data is stored in systems, my data is stored in systems of vendors that I don't even know about. If we wait until this gets worse, when you look at the current slope of these attacks, that's too late. Too much damage is going to be done, so this is something that we do need to get ahead of a little bit. And then that final piece, we're all interconnected again. Every company is kind of dependent on the decisions every other company makes. We can't fix this ourselves. Even if one company or group or project is doing everything to the best of their abilities, they can still get affected by somebody else that didn't follow all of those best practices. Kind of pushing and rising up that tide of security best practices is something the government is perfectly positioned to do and needs to do for us to continue relying on software and software systems. So for that first one, concentration risk, I pulled up this old picture. There's a really good analogy here that I like when we talk about this risk, and this was the financial collapse in 2008. I was in college in 2008, and we had a career fair scheduled for a week after this happened, and it was a ghost town. All of the companies that were supposed to be showing up to hire, the booths were unmanned. There was this joke that all the people showed up anyway to pass out their resumes after instead of coming to hire people at college. But I think this is actually the right analogy when looking at open source risk. It's kind of the too big to fail one rather than the other one you kind of hear troped out a lot, like the tragedy of the commons. Open source is not tragedy of the commons. A tragedy of the commons problem occurs if there's some shared resource like a park or something that everyone walks in, throws their trash in, and no one's incentivized to clean it up. That's not correct. Using an open source project does not weaken it. It doesn't take anything away from the project. In many ways, it strengthens it. More people know about it. More people know how to work on it. You might get more contributors too in the end. But in no way does it weaken a project when more people use it, whether or not they're paying for it. I think the better analogy here is too big to fail. Where the consequences of a breach in a project get too large for the government to ignore. It presents this systemic risk. If you look at Log4j again, that software was running everywhere. They handled it well. Every project has bugs. Every line of software has a chance of having a bug in it. I write software. The more software I write, the more bugs I write. When something like that gets used so universally and so worldwide, there was even this tweet that turned out to be false after that vulnerability, but NASA was bragging about how Log4j was running in the Mars rover. It turned out that wasn't actually correct, but I call that the first interplanetary software vulnerability. It wasn't actually running there, but when something like that just gets so widespread, the risk gets so magnified of a bug in something like that. So it's not just the quality of the code, it's also the criticality of the environments that it gets used in that present this risk. And that's why the too big to fail analogy fits better for me. The second point, everybody mostly uses the same stuff. If you want to let the market regulate something without having the government kind of step in, you'd have to imagine this world where there's tons and tons of projects out there that all have different security standards and they're all interchangeable. And if you just make all of the right decisions when you're writing software, then maybe you won't get breached. And one of your competitors that made wrong decisions and picked the worst versions of all these libraries does get breached. And hopefully over time the market would correct that and we'd buy products from vendors that pick the better solutions. That's just not the case in open source. I can count on like 2 fingers the number of cases where there are actually 2 equally fully featured versions of a library that can do all of the same things in the same programming language, and you actually get to make that choice. That's just not something developers do on a day-to-day basis. You pick the best one because it is the best one, and there's usually only one really good option for all of these programming languages and features and APIs you're trying to integrate with. Sure, there could be a ton of small ones, but that's not actually a healthier state either. Healthy projects have large communities that take a lot of people to come together around and maintain. That's the way the open source kind of contribution economy works. The more people working on something, the easier it is to onboard new maintainers. Collecting people around critical mass in those projects provides healthier projects and more secure projects for everyone to rely on. We don't want everyone to pick their own request handling library or a different cryptography library. We're all better off if people are using the same cryptography library that all of the cryptographers in the world are reviewing and working on together, rather than having a whole bunch of these different choices. So when you combine kind of these 2 dynamics, you get this systemic problem where everyone is using that really good library that everyone is working on, but the consequences of a vulnerability in that library, which is eventually inevitable, presents a systemic risk. Then that final point, the attacks are rising dramatically. That first graph on the left is open source package downloads, obviously shooting up like crazy. I think this is just for the NPM ecosystem. But then there's that scary one on the right of attackers now starting to pay attention to this and plant malware in these libraries. Security is unfortunately a cat and mouse game where attackers pick the next easiest attack point in, and then the whole industry kind of has to rush to get on top of that. So in some ways, I see this as a success in other areas of cybersecurity, right? We're not all reusing passwords across websites, storing them in insecure ways. 2-factor auth prevents most phishing attacks. So the next easiest way in for bad people on the internet is to start trying to hide malware in these open source packages. It's scary because we haven't had to deal with this before. You can kind of see that slope starts in 2021. Only 3 short years later, this is now a buzzword that everybody's kind of confronted with, and new malware is discovered on NPM and PyPI and Ruby gems every single day. Because of this slope, it's something that we have to get ahead of before bad things happen. Then that interconnected piece. Even if you do somehow write and review all of the open source code that you're using and completely harden yourself, you can still be affected by a vendor. You can still be affected by someone else that has your data or somebody else that passed off your data to somebody else down this supply chain. There's no possible way for any one organization to completely harden themselves from an open source supply chain just because we're all interconnected here in this complicated graph. Everyone has to do this together for us to really benefit. That's hard in one aspect because it can make your work feel useless if you do everything you can and somebody else that you work with hasn't, and you can still get compromised as a result. But it means that we should all take the same steps at the same time, and having government regulation is one way to do that, assuming the regulation is set up correctly. The final piece, I hope this one kind of really drives home the criticality of this. This is just a random ChatGPT thing. I asked it to generate of places open source is used. Yeah, it's everywhere from toasters to cars. Kubernetes is running inside of fighter jets today. The software that you're using is running in places you might not even realize, empowering literally every aspect of your day-to-day life, not just the web apps or SaaS systems that you interact with where you would think it's running. So hopefully I've convinced you that regulation could help here as long as it's done correctly. Now I want to talk about how I think there's a right way and a wrong way to regulate open source. This is an exercise I really like to do, so we can try to make this a little bit interactive. But I love this Dwight Schrute quote. Whenever I'm about to do something, I think, would an idiot do that? And if they would, I do not do that thing. Anybody seen The Office? It's a very good decision-making principle. But if we're going to try to talk about the right way to do open source regulation, it's an exercise I like to do inside our company all the time when we're talking about strategy or something like that, you can first flip it around and have everyone kind of brainstorm what the worst possible way to do something would be. And then it turns out that if you just flip those worst possible things around, you get to a pretty good outcome. It might not be a perfect one. But so let's do that one here. If you're told that the government is going to regulate open source, what would be the worst possible way to do that? Who wants to go first? Okay, yeah, so everybody has to mail, all open source developers have to mail their source code to the government, and then you'll review it and send back a certificate. That sounds kind of like FIPS cryptography. That's a good one, in the back.
That they write it into law that the source code must be a specific series of code.
Oh, okay, yeah, so they write something very specific into law around maybe the technology used or practices that have to get used. Yeah, I could see that being terrible because laws take a very long time to pass and to change.
No source library may be published unless the vendor has sufficient financial and legal resources to be able to apply, pay out if misused.
I can tell you've read some of the regulation drafts, but yes, yeah, so you can't publish open source code unless the vendor, you said that clearly, we'll talk about that a little bit more, has the resources to pass some legal and compliance checks, so make it even harder to publish code. Was there one more in the back? You must publish what? You must write certain data? Oh, write your code in Ada. Okay, yeah, so pick a very specific technology, one nobody in the world understands today, and require that everybody doing open source uses that, yeah. Cool, okay, yeah, so these are all some. I had some of my own. We had some overlap. But yeah, pass laws regulating what maintainers can and can't do on the internet. Telling them they have to use specific technologies, telling them that they have to mail their source code to the government. That's fraught with so many different problems. It's a free speech issue, right? Publishing code on the internet, anybody can publish whatever they want on the internet, whether it's code or not. This was tried a long time ago to regulate encryption export by treating encryption as a weapon. People like literally printed the RSA algorithm on t-shirts and wore them through airports as a way around that. You can't really regulate speech this way, and trying to make people's jobs harder never works. Mandate specific technologies and practices. Yeah, we had a couple of those. Anything like that written into law is going to be out of date tomorrow. There's new programming languages and new practices constantly. We see this with stuff like FIPS, where older encryption is mandated even though there are better options available out there today, because this stuff just takes so long to change. A specific programming language would be even more fun. Mandatory government backdoors. We've seen this one come up a lot, especially in the encryption space. If the government can't crack encryption, then they can't monitor what's in there. But it turns out that if one person has a key to something, other people are going to get that key over time too, and it's going to lead to worse security for everyone. And this final one, yeah, blaming the developers, right? People are just publishing this for fun on the internet. Sometimes they're motivated by trying to make money off of it. Sometimes they're just doing it for fun or just pushing things forward. If you had consequences to the people writing this code, it would add friction and fear and scare everyone out of publishing open source, and we'd end up in a much, much, much worse state. So if we just want to flip this around a little bit, you can end up with some pretty good strategies for how to actually force governments and companies to use open source more securely. That's the main point here. Open source is fine. It's doing fine on its own. The way people use it has to change. So instead of passing laws regulating maintainers and specific technologies, pass laws or write regulations around the way companies use that and force them to do updates and keep track of what they're using. Make sure that they are responsibly selecting projects where they can, and make sure that they're patching the vulnerabilities that are found when the projects do a great job of releasing them. Don't do anything technology specific, but have a standard set of best practices that can be met with any programming language or any technology. And whatever you do, don't pass laws that would move liability onto the maintainers of the projects. You have no business relationship with most of these people. It's your fault. It's right there in the license. It says this software is not deemed fit for any usage in most of these. It comes with no liabilities or warranties. When you make the decision to include a piece of software in a critical system, that's on you, not the person that published it. They might not even know it's being used in those places or ways, and they would probably scream and call you a bunch of names if they found out some of the places that their software is running. It's always terrifying for me when I put something up on the internet for fun, like a weekend project, and then months later I start getting bug reports on it from people using it inside of banks or inside of crazy places where they need code added. I don't even know if it works. I wouldn't recommend anyone use a lot of the stuff I write, and yet they do anyway because it's on GitHub. So that's the main point. I think the right way to do this versus the wrong way. It has to center on the companies that are integrating it into systems that deal with sensitive data. Now, the government has a couple different tools to do things like this. There's this old saying, these are the main three ways the government can help out when they come. They can send lawyers, guns, and money. Lawyers are the ones that write these laws, they pass regulations, they can change codes, and they can file lawsuits, like we've just seen in the last week, if companies don't handle disclosure properly. The guns one, there's a lot of angles to cybersecurity, especially when it comes to nation-state attacks that are targeting people. A lot of these cases, these attacks are an act of war. When people hack systems that are then used and brought into environments to steal data from the government or steal data from companies. Laws that threaten to throw people in jail and pass criminal liability if their source code is vulnerable too kind of fits into this category. And then the final one, money. Open source does have a sustainability problem in a lot of areas, and the government is relying on more open source than anyone else out there. Grant programs are hard to do and hard to execute, but they can work when they're targeted and when they're run correctly. You can drive massive improvements by figuring out the right areas and the right places to improve security. We heard this morning a little bit about the memory safety initiatives. There have been a lot of grants on that, and the work that they've done is incredible by moving low-level code that's been written in out-of-date languages with out-of-date practices to more modern ones. And these are low-level things that everyone depends on. So you're probably running software that's benefited from these programs without even realizing it. And by being able to do that at such a low level, you can affect change for everyone at the same time. To wrap this up, there are unfortunately some examples of people that are doing this right, and unfortunately some governments that are doing this the wrong way. I can see David starting to smile. I know David's been watching and doing the best he can for the last couple of years to correct some misinformed initiatives. But first and foremost, I think the US government is actually doing a pretty good job here overall. With a couple areas that I think are slightly misguided. But I think the national cybersecurity strategy that came out last year from the Biden administration was great. It was multi-pronged. It hit every single element here. A lot of it hinges on kind of setting a set of standards and best practices that I'll talk about in a bit that apply to the whole way software is built, not just the way that it's operated. Most of that is in this massive document called the Secure Software Development Framework from NIST. But this is one of the first acts that came out of the SolarWinds breach, was to codify best practices for software development. I'll talk about exactly what that looks like more in a bit. The US government is also the largest software buyer in the world. And short of passing laws, they can try to do their part by only wanting to buy software that meets these standards. You don't need to force anyone to write that, but if you're only going to buy software that's secure and you happen to be one of the largest software vendors, that goes a long way. Then harsher penalties for criminals. Unfortunately, security is a multiplayer game, and if everybody in the world was good and nice and as well-intentioned as everyone here in this room is, I hope, we wouldn't have to worry about any of this. We could just go back to building products. But unfortunately, that's not correct. and people are out there trying to ransomware, crypto coin stealing, data theft, all of that. By coming at it from every angle, we can both reduce the risk of an attack and also provide more penalties for people that do choose to do that. The final piece here, liability reform. This has been a big one. The EU just announced some stuff last week, but it's been a big item in the US policy agenda for a while too. But changing the way liability in software works to hold vendors that don't actually meet those best practices that were just kind of codified in the first bullet here. If you don't meet those best practices, then changing the way liability works. So if you're affected in a breach, you'd actually have more recourse. And you don't just get one of those like $2.50 checks in the mail later or free credit monitoring every time your social security number is leaked on the internet. By combining all this, you can change the incentives around the way people produce software to result in better outcomes for everyone that depends on software. So the first part here, the Secure Software Development Framework from NIST. I think this is about 80 pages long. Half of it is references to other documents. But this is an example of a group working with industry to figure out and codify the best ways and the best practices to build software. When the way this gets rolled out to everybody else, though, is a separate piece. But this is kind of the first time, I think, in history where the government, through a standards body, has actually produced recommendations and best practices that if you meet these, then you're following the same best practices everyone else in the industry is. I've read every single page in this document. Has anybody else actually read this whole one? I know David has, so I'm just saying, yeah. It's very long, it's very good. It's very well written, it's deep, and it kind of runs the gamut from like obvious things everyone should be doing to some best practices that I don't think many people in the world are doing yet, and it's gonna be a stretch for a lot of people to really comply with every single element of the SSDF, and it's gonna take a while. But we have a direction that we can all kind of point in, and we can all use this as ways to convince our employers to let us work more on security and to do things that will actually improve security. When the government writes something down, it tends to have a lot of power and have a lot of backing inside of it, for better or worse. The liability reform piece comes hand in hand with that one. What this really means is kind of, this analogy I think is a good one. Every time you sign up for any website, there's usually a button like this one where you accept the terms of service. I won't ask if anybody reads every single one of these that they click. I don't think that's possible. They're too long and they change all of the time. But in most software purchasing and most sign-up agreements like this, there's a clause that says the vendor is not liable for any security breach. And that's why you don't get much recourse whenever hacks happen. When you combine changing the way that that liability works by making it harder to add that clause inside of contracts and to enforce that clause with the best practices that have just been codified, we kind of set this bar of negligence. There hasn't really been a real definition of what's negligent in software. When you combine that with the fact that even the most secure companies out there can be breached, there are folks out there with just as much budget or more budget and more patience and more time than even the best security teams out there. If a breach is inevitable, then kind of why try? That negligence bar is the big one. Just like if you go in for a surgery and there's an honest mistake from the doctor, these things happen. But if a surgeon shows up drunk and leaves a scalpel inside of you before suturing you back up, that's malpractice, that's negligence. We haven't really had that concept in software. And now that we have kind of these best practices that everyone understands and knows and have been done in collaboration with industry, you can kind of start to set that bar. And that's what a lot of the liability reform initiatives are really about. If you get breached because somebody spent billions of dollars trying to crack your state-of-the-art encryption that everybody else in the world was using because it really was the best available at the time, that's one thing, right? This can hit anyone. But if you get breached because you forgot to encrypt your passwords that were just sitting in a database open to the internet, right, that's very different. And that we're kind of setting that bar of negligence and setting that bar of malpractice and gonna make it easier for end users that are affected by this, the real victims in these scenarios, to sue financially and to get recourse and to get damages for times like this, when there's really no excuse for making a lot of these low-level mistakes. One aside, I just had to throw this one in. This is one of the other major policy initiatives from the US government, one of the areas where I think they're probably not doing all of this correct. There's this huge focus on software bill of materials, and they do have a role, but when you kind of stack rank producing a software bill of materials with all of the other ways breaches can happen and all of the other places people should be spending their dollars and time to improve their software supply chains and the way that they build software, this one, for some reason, gets like 90% of the attention and oxygen in any conversation and probably provides 1% of the benefit, in my opinion. opinion, versus all of the other places that we could best be spending our time and money. And the reality is everybody is budget constrained and time constrained. And when you force people to spend time on something that doesn't move the needle as much as something else, then that results in worse security outcomes for everyone. Over to the flip side, though, the wrong way. This is mostly coming out of the European Union and the Cyber Resiliency Act. Some of this was just passed last week, and they have made changes to it over time, probably largely in part and thanks to David's relentless, tireless work to explain that open source maintainers are not vendors and there is no commercial relationship set up with a lot of these. But the first versions and first drafts of this were frankly terrifying. It was going to place liability on the maintainers of open source projects if their software resulted in a breach of a company that was using them, regardless of whether the project had any commercial relationship, expressed any fitness for use or purpose, or even knew they were being used in these environments. It was so terrifying at first that if you publish code and some, say, bank or something in Europe used it and resulted in a breach, you would personally be liable for that breach, even if you'd never met anyone and they never gave you a dime. Software doesn't work that way. Contracts don't work that way. It's gotten a little bit better over time, but the version that's passed still fundamentally confuses vendor and commercial relationships and open source. So it's not quite as scary, and foundations like the Linux Foundation and the OpenSSF can kind of step in and shield projects a little bit from that. But it's still not perfect, and it's still the complete wrong direction to be looking here. You can't just pass a law that says all software must be secure and then threaten maintainers that have bugs in their code. That doesn't work. The right place to put this is on those commercial relationships. If somebody does pay you for giving them software, they should be able to place demands on you and get guarantees about the security of that software. But until that contract gets reviewed and signed, you owe that person nothing, and you shouldn't be responsible for any of the outcomes that happen from using that software. Placing it on the supplier and not on the consumer, it's about as backwards as it can be. They don't go as far as mandating everyone use Ada, the programming language, or anything like that. But it's kind of completely pointed the wrong direction, and is going to harm open source if it actually gets rolled out in the way that it's set up.
So
Yeah, go for it.
so, you know, at least like project I did, in my terms saying, not open source license, not allowed for use in the European Union. Sorry, kids.
Yeah, and then that doesn't meet the definition of open source anymore, and you're going to run into a bunch of other headaches, basically. But yeah, software used in the EU could be burdened or governed by this act, even if you've never been to Europe.
Yeah. So then, so next thing you know, they're like, and come to court, you're like, I've never been to Europe.
Yeah, and it gets especially complicated with things that are like vendor associated, or if you happen to be working on something as part of your day job at a company, and I think that's where the policy still currently is vague. If it's produced in conjunction with commercial activity, a lot of the policies still apply, even if your company or whoever's sponsoring your work doesn't actually do any business in Europe. If you're doing it in your spare time completely for free, you're probably okay now, but I'm not a lawyer, and I'm definitely not your lawyer. But anything related to anything that could be commercialized is still in the scope of a lot of these mandates. And yeah, you jumped ahead a slide basically, but yeah, just think about the effect this would have on you or the projects you work on if everybody has to start getting worried about which jurisdictions are going to use their software, even separate from anybody that's actually paying you. This is one of the scariest things that I've seen happen to open source in a very long time. So that was my overall rant on how to do regulations correct and incorrectly. I kind of just threw in this one last one. Europe kind of has this reputation at this point of passing bad intention regulations that have downsized impact. That's not the way that we do innovation. That's not going to produce better outcomes for anyone. So thank you all.